Questions off the packet?
2.
5. Front page.
That works.
5 on the front page.
I mean, there's 2.
You have to tell me the page and number. All right, let's just start copying some things that we know. If this segment right here is 12, what do we know about this segment down here?
It's 12.
So we put that in there.
Okay.
If this angle's 3x, what's this angle?
3x.
Also, this one over here, because they told us those were congruous, that's 3x. If this segment's 2y, what's this segment down here? 2y. I don't know if any of this will help us or not, but we'll try it. If this angle right here is 90, what's that angle right there?
Pardon the interruption. I need the following students to come down to the high school
All right,
office.
so we know all
Alex
that.
Kale, Austin Rao, Sierra Dixon, Dom Huffman, Michael Newman, and Paige Matthews.
First thing I'm going to do, see this triangle over here? This is what you should always look for. Stuff like this that you know is easy. What do you know about the 3 angles of a triangle?
Take 180.
They add up to 180. Do we know something about all 3 of these angles? So could we set up an equation?
Yeah.
What's the first angle?
3x.
Plus, what's the second angle?
3x.
Plus, what's the third angle?
90.
And all 3 of those should add up to equal. Should add up to equal.
180.
Oh, sorry. 3x and 3x give you 6x, right? Subtract 90 on both sides. End up with 6x equals 180 minus 90 is 90, right? Then what? Divide by 6. Get your calculators out. And what's
579.
what's x equal? 15?
It's like the second last problem.
Oh yeah, I did that one wrong.
That's part of our answer.
I said
Now to find y, well, y is this. The bad thing is, can we just set 2y equal to 2y? That won't work, will it?
Do we have to combine it? Can we combine it?
When you get to a point where you're not sure, what I would do with any of this stuff, if I take this x equals 15, can I go back up here and figure out exactly what this angle is? And start figuring out stuff that you know. What's 3 times 15?
45.
So this angle right here is 45 degrees. What's this angle over here then?
45.
What's this angle over here?
40.
Now look at that triangle that we had just talked about a few minutes ago. Let me split it off over here. It looks something like this. That's a right angle. What's this angle?
45.
What's this angle?
45.
Is that anything special?
Yeah.
Yeah, it's a 45, 45, 90 triangle that we talked about here not too long ago, right?
Right.
Sides across from the 45-degree angle should be labeled L and L. Side across from the right angle, L times the square root of 2.
So because that's opposite.
Well, now look at what we have here. How long is this side? So what's L have to equal? So if that's 12, what's this side over here? 12. That doesn't really help us. That's this. And we could say this over here is 12 also. Doesn't really help us, but it's all stuff that we know. This part down here is supposed to be 2y. Well, we now know that L right here is what? What did you tell me L was? So this side isn't just L times radical 2, it's 12 times radical 2. Well, that 12 radical 2 should equal 2y. So we set up that equation. 2y equals 12 radical 2. Let me do this. If I cover up that radical 2, how would you solve that for y? Divide by 2. Guess if I take that off, guess what you still do? Divide by 2. These cancel. You're left with y equals, what's 12 divided by 2? So 6. Radical 2 is what y is. Is it alright to leave it that way?
Yeah.
Yeah. Could you change it to a decimal if you wanted? Yeah. Why though? It's just more work, right? Next question. Everybody got this one so I can erase it? Give me another.
I feel like the
6 on the next page.
6 on 426.
I hope they won't I didn't pay attention.
Alright, I won't do 6 because all those deal with one problem. So what we'll do, just like I've done all year long, is we'll go through and figure out everything we know about this shape, and then you can go back and fill in the answers. Alright?
24 each on 3 pages.
30 degrees, 25 degrees, 23, 4b minus 1, U, R, S, and T. If this angle right here is 30 degrees, name the angle for me that's got to equal 30 degrees. Name the other angle.
RTU.
RTS.
Does everybody see what Brian said?
Yep.
Remember, it's this angle. What should it form? N or Z, right? So it's this angle and this angle. So that's 30 degrees. What's this angle going to be? 25 degrees. Now, did they draw the other yeah, they had the other diagonal drawn in there. Sorry, I forgot that. Do you know how much this whole angle is? What would you do with those two? Add them together, what do you get? 55. What's this whole angle down here? 55. What do you know about consecutive angles? So this angle and this angle. What did it say in our notes last time? Consecutive angles have to add up to 180. So if that whole angle is 55, how would you find this whole angle?
Subtract 55 from 180.
I'm not doing it for you, so 180 minus 55, what do you get? That's what tells us this whole angle. Don't listen to Cody. He's wrong all the time.
Something like that.
125.
What is it?
125.
125?
Boom. Yep, Cody.
You got it wrong the first time.
How much is this whole angle then?
125.
Let's see. If we're dealing with the sides, this side over here is 4b minus 1. What's it got to be equal to?
Right here.
Can we solve that?
Yeah, add 1.
Add 1 to both sides, you get 4b equals 24. And remember, the reason for that, the reason these two are equal, opposite sides in the parallelogram have to be congruent to each other. Divide by 4. What's b equal? We can't find these angles. You can't just say, okay, I know this whole thing's 125, so that's half of it or anything else. We can't find these angles, but I think that's all we can find for the information they gave us in that shape. And I bet that answers every one of those questions 6 through 9. So take a minute, make sure you got all of them. I'll leave this up here for a second. Oh no. Cancel, cancel, cancel. Shoot.
Keep.
Now if I hit keep, then it's going to stay on there forever, and I don't want it to stay on there forever.
Can you just move that box?
And just
There you go. Put it, yeah, there you go. See, that looks too, it's like-
The whole purpose was for me to be able to stop the recording, and I can't now, so. Tell me when everybody gets all their answers. Again, you should be able to answer 6 through 9 for that whole, from all the stuff that we have there. If you have trouble, ask. Get them all? Everybody get them all? Yes, no, maybe?
Yeah.
Yes, no, maybe, McKenna? You got them all? You lying to me? How much is it?
The problem is 29x squared plus 64x, or 64y squared equals 2,136.
Yeah, I'll pass.
Now you got it?
Yeah.
It's too big.
No, I don't need to stop. Give me another one.
10 on the front page.
10 on the front page. It's going to take me longer to do this than it's going to take to do the problem. They say segment AD is parallel to what? Segment AD is right here. Which segment's it parallel to? All of those, all of them that look like that for the whole packet, that's all you're doing. So if we go back up to number 7, angle BAC, that's this angle right here. Somebody tell me the angle it's going to be congruent to. DCA. That angle right there. That's all you're doing is naming the angle or the segment or whatever for that certain thing. Give me another one. Brian should be working on his algebra too, because I'm walking over there tomorrow when you're in Mr. A's class so I can watch him hit you.
10 on 4.6.
He hit me when I was in his class. I'm going to watch it so he hits you.
Wait, you were in this class?
Number what on what?
10 on 4.6.
Mr. A used to have to ride a dinosaur like Rick
Oh my god.
That's funny. Don't be in his class again. Number 10.
Okay, we can say a Model T. Is that even more developed? You know, my dad was pushing Model Ts than Mr. A was.
I'm trying to think of the car that would be.
He probably rode in like a 55.
Station wagon.
We'll say that.
So we got this. They want us to find the coordinates of the intersection of the diagonals of the parallelograms. So we're looking for.
You didn't label or.
Sorry.
Which one's this?
Number,
This is number
10 on the
4.6.
426. There you have it.
Yes.
So these are the diagonals. Remember, these are the diagonals. What do you know about the diagonals of a parallelogram? What do they do to each other? That's true.
Bisect.
They bisect each other.
Same.
So wherever they intersect right there, that should be the what for both of them? Midpoint. Guess what formula we're going to use to figure out the coordinates of that?
Midpoint, okay, I
The
got
midpoint
this.
formula. Now, this time, since they told us it was a parallelogram, all we really have to do is find the midpoint of one of them. If they wanted us to prove it was a parallelogram, we'd find the midpoint of both and make sure that it matched up. But this time, since we already know it's a parallelogram, we just pick whether we want to find the midpoint of segment PY or the segment or of segment ZR. So you guys pick, I don't care which one. PY or ZR? ZR. So what we need to do is use the coordinates that go along with Z and R and plug into that midpoint formula. So looking at the points Z and R, so I don't have to look back at my paper. What are the X coordinates for Z and R?
X coordinates is -3.
-3 and what?
3.
Make sure that she's telling me right, because I'm not looking at my paper, and if it's wrong, you guys just have the wrong answer. How about the Y coordinates for Z and R?
-1 and 3.
Now what we do is do the math. What's -3 plus 3?
0.
0 over 2. What's -1 plus 3?
+2.
over 2. Now we do the division. What's 0 divided by 2?
0.
2 divided by 2?
1.
That point right there should be 0, 1. Does my point look like it's fairly close to 0, 1?
Yeah.
Yeah. Even with my terrible drawing, it still looks like it's fairly close.
So is that the same thing we do on 11?
Yep.
Okay.
Anytime they give you coordinates, what's the first thing you ought to do with it? Graph it. So you can see it. Even if it's just a little graph that you draw on your paper, where it's something like this, and you plot the points, just so at least you can see that, hey, this is A, this is B, this is C, this is D, so that you can see where each thing's located, if nothing else. Give me another. Don't all you guys let Derek ask all the questions either.
Well, I'm trying to get one off every page so I can know how to do the examples.
Huh? Yeah, you did help.
Okay, I just have a serious question.
3 on the 3rd page.
We're on the 3rd page.
That answers my question actually. Do you just do like what it says, like slope formula or?
Yep.
Okay.
So first thing we're gonna do is what?
Graph.
Graph it. So that's what I'm gonna do first, and we'll graph this. So give me a second to graph it, and again, there's graph paper up there, so if you need it at home or whatever.
Where is it located over there?
You said problem, yeah, over there on the shelf where it says graph paper. You said number 3, right?
Do you have a calculator in here?
-1, 0. You just need a regular calculator, and you need to walk in that back room back here. To your left, there's 2 white boxes. -1, 0, that's R. 3, 0, that's S. 2, -3, it's T. And then -3, -2, that's U. And we're trying to decide whether that's a parallelogram or not. Do we just look at it and go, no, that's not a parallelogram? No, because you know my drawing's probably wrong, right? They want us to use the distance formula. So in other words, what we're going to be doing here is we're trying to say these 2 sides are congruent and these 2 sides are congruent. Well, if I look at this and I've graphed it and I don't believe that it's a parallelogram, then what I would do is pick the sides that I think are for sure wrong. So that way I can do one thing and then be done. All right? So which 2 sides do you think you might pick here? I'd probably pick RS, and what sides does it have to be equal to? If this was a parallelogram, or if it is a parallelogram. UT. Good. So if those 2 are equal, then we know it's a parallelogram. Well, for RS, that's an easy one, because do I even have to do that big long distance formula? No, it's a horizontal segment, and all I got to do is count. How long is segment RS? Four. If it's horizontal or vertical, you can just count and find the length of it. Now for UT, help me out, because I'm not going to look back at my paper. For UT, we actually need to use the distance formula. Remember, it looks like this. We need the x coordinates for U and T. What are the x coordinates? So everybody know that x comes first, then y, right? So for U and T, what are the x coordinates?
-3 and
-3 and what?
2.
Everybody agree with that? Yes, no, maybe? How about the y coordinates for U and T?
-2 and -3.
What's going to happen when we put a -3 over here?
It's going to be a come positive.
Change plus, right? Now we do the math. Have out your calculator so you can help me here in a minute. What's negative 3 minus 2? Negative 5. Then let's go ahead and do this. What's negative 5 squared? Be careful. Negative 5 times negative 5. Grab your calculator again if you need to. What is it? 25. Over here, what's negative 2 plus 3? Positive 1. What's 1 squared? Probably have to grab your calculator for this one. What's 25 plus 1? Yeah, okay, I have her calculator already. Square root of 26. Grab your calculator. What's square root of 26? Yeah, you can. It's going to give you a decimal answer, but you can do it. Is your calculator not giving you a decimal answer? If it's not, I need to know so I can change it to the right.
Well, I wasn't going, I just knew from the last problem.
5.09. How many decimal digits do you want?
I don't know, so 5 point, you said 0.9?
Yeah.
So we'll say 5.1. So segment UT is 5.1 units long. What's that tell us about those two? Are those two the same? So not same. And if those two aren't the same, then what's that tell you?
It's not a
Not a parallelogram. Next question. Four on the very back. They give us a shape looks like this. Got that, you got that, you know this, you know this. And it says determine whether the quadrilateral is a parallelogram. Remember, we had 5 ways to prove it was a parallelogram. First way, both pairs of opposite sides were parallel. Second way, both pairs of opposite sides are congruent. Third way, both pairs of opposite angles are congruent. Fourth way, terrible drawing. Diagonals bisect each other. Then the fifth way was the hardest one. This pair of sides are congruent and parallel to each other. Does this picture fit any of those pictures?
Oh, yeah, it just says right in the standard.
No, so what's that tell us? Not a parallelogram.
Maybe like negative 1/3 y equals x squared.
Now they said justify your answer. I don't know. It doesn't fit any of those. I don't know what else to put to justify your answer. If it did, if it was a parallelogram, then it's easier to say why it is. But it's sort of hard to say why it's not. Give me another. 7 on the very back. Ken, am I going too fast for you? Can we go faster? I'm going to tell them to put you in my intervention again next year just so you can have me again. Before I write down anything else, what do you know about those two angles? They should be equal to each other. So tell me what equation I can set up.
5x plus 29 equals 7x minus.
Somebody's going to solve this and tell me what x is here in a minute so that we can get more problems done. I'll solve for y. What can you tell me about these other two angles? They should be equal to each other. Is that right? I wrote something wrong. Dang on it. 5y minus 9. So this one, that should equal that. I'll solve for y. Somebody else solve for x. Should be 2 or 3 of you solving for x because I don't want to trust just one person. One of you might want to solve for y just in case I screw up. I end up with y equals 12. Anybody get x?
It's
20?
20.
Everybody agree with that? Amy, you agree with that?
Sure, I solved it.
Give me another one. Are you looking at me? Oh, funny. For Nick, you need me to do a problem?
Yes. So refresh my memory.
Are we done with geometry? And I could do a problem for Nick real quick. You guys can handle the rest of them?
Yeah.
Everybody except for Jonathan. All right.
You have to give him a page.
Number 5, 424.
Number 5 on 424. Number 5 on the first page. Everybody follow along helping? The quicker we get through stuff, the more problems we get through. First thing, before we go any farther, before we start trying to find anything, if this segment right here is 12, what do we know about this segment?
12.
So let's write it in. If this segment's 2y, what do we know about this segment?
That's 2 on.
This angle's 3x, what do we know about this angle? This angle's 3x, what do we know about this angle? 3x, because apparently they were the same, right? Now let's look up here. If this angle is 3x, what do we know about this angle up here? It's 3x also. I don't know if we'll need all this or not, but stuff that we know. If this angle right here is 90, what's this angle down here?
90.
So we know all that stuff. We could actually go a little farther and say that this angle right here is 180 minus 3x, but that's probably going a little too far. All right? Once we have all that, now let's try to set up an equation to find either x or y. I'm going to do x first. Whenever you're doing this, what do we have a lot of in these kind of pictures? Triangles. What's the one easy thing that you know about triangles?
Yeah, like,
The angles add up to 180. So I look at this triangle right here. Do I know something about all three of those angles? They add up to 180. Tell me the equation I could set up. Give me one of the angles. 3x. Plus, give me another angle. Plus, give me another angle. Help me solve that. What do we do?
minus 5 yards.
Mine x's.
That'd be 6.
Be what? Didn't even put that. Now what?
Subtract 90.
6x equals 90. Have your calculators out. If we gotta wait, I'll wait for the whole 20 minutes. It doesn't bother me. So have your calculator out and be ready to help.
It's 15.
Part of our answer. Now we gotta find y. Well, the bad thing with y here, we know that these two are equal. But if I set up 2y equal 2y, is that gonna help us?
No. Never know.
Because that's just going to tell us y equals itself. Alright, so that won't help us. When you come to a point like that where you're not sure what to do next, we just found x. Can we use that to find some other stuff in this?
Yeah.
So let's go back. If this angle right here is 3x and we know x is 15, how much is that angle? Grab your calculator. 45. Anybody else agree with that?
Yeah.
Your sister, keep your calculator. What's this angle right here then?
45.
What's this angle?
45.
Getting the,
This one up here is 45 also.
Yep.
Let's look at this triangle over here. My picture's drawn terribly, because that should be a right angle, right? So it should look something more like this. That's a right angle. This angle right here is how much?
45.
45. What's this angle?
45.
Wow, have we ever seen any triangles that look like that before?
Yes.
What were they called? 45, 45, 90 triangles. In a 45, 45, 90 triangles. The sides across from the 45-degree angles, anybody remember what they should be labeled? And the side across from the right angle should be labeled L radical 2. We know this side. So what's L equal? L equals 12. How long is this side?
2
Well, you're right, but let's just look at this for now.
Oh, plug the 12 in, that's right.
So what do you get?
So,
12 radical 2.
12 radical 2. 12 times the square root of 2. Now, here's where you got to be careful. Is that our answer? No, we know that that segment also equals 2y. So 2y should equal what we just came up with, 12 radical 2. What if I cover that up? How would you solve for y there?
but it'd be 6.
Divide by 2, right? Guess what happens when you put the radical 2 in there? Guess what you still do? Divide by 2. It's the same. Right? So we divide this side by 2. We divide this side by 2. And now it's not just 6. It's 6. What else is still there? 6 radical 2. 6 times the square root of 2. I'll write it down here so we can see it a little better. So x equaled 15 and y equaled 6 times radical 2. Now, Riley doesn't like the 6 times radical 2. Could she grab her calculator and turned all that stuff into a decimal a long time ago and wrote it out that way? Yeah, go right ahead. Mr. Eversole's intelligent enough that he'll know that if you got 9 point, or it's actually 8 point something, if you got 8 point something written down, I'll know that that's the same as 6 radical 2. Next question. 12 on 426.
What number?
12 on 426. You can skip that one, just mark it out. Yep.
Probably mark right below.
Yeah.
Okay.
Next question.
3, front page.
3 on the front page.
Not understandable.
Same here. I guess the first one's working because it was really easy.
Better understand it because this whole chapter is this way.
Okay.
Yeah, I don't understand what I asked.
That angle's 60 degrees. This angle's 2x. That's congruent to this, which is congruent to that, which is congruent to that. This angle over here is 4y. Let's see what we know here. Now, later on in the chapter, this is going to be a real easy problem because right off the bat, when you look at this and you see that all these sides are congruent, this angle right here is going to have to be a right angle. But the bad thing is, do you know that now? No, because I haven't taught it to you yet. So we don't know that yet. But later on in the chapter, this will be an easy problem because that's going to be a right angle. That's 60. Could we find x pretty easily? Yeah. And then once we find x, we know that these two angles are the same. We could find y pretty easily. For now, we don't know that, so we got to figure out something else. If we look at this big triangle, what kind of triangle is that big triangle right there? Thank you. So if this angle is 2x, what's this angle up here? 2x. Look at this triangle.
Same thing, 4y and 5.
So this is 4y down here. Let's see if any of that helps us. If we look at this triangle,
60.
what do you know about this angle right here? 60.
That's all we got. Right?
I bet we can find more.
Wouldn't all four of this right there, that corner would be 60 for all of them?
For all these?
Yeah.
I'm not sure, are they? How do we know? Let's look at this. What do you know about this? Look at the two angles I'm tracing. Clayton's on the right track. What do you know about that angle and that angle? They're the same. So if that's 2x, what's this angle? 2x. Oops, 2x, not 20. Now Clayton's on the right track because if we go this way, what do you know about that angle and that angle? It's got to be the same, so that's 60. What's this angle up here then? 60. Now, let's look at this triangle, the top one. If I split off that big triangle up top there, what can you tell me about this angle right there? Be careful.
It's 120.
It's 120. What's this angle?
2x.
What's this angle? Can we figure out what x is? 2x plus 2x plus 120 should equal 180. Somebody solved for that for x. Let's do the same thing for y over here. What equation can we set up there for this other triangle? Do I need to draw it off?
4y
4y
plus 4.
plus 4y. Be careful. Plus 120 equals 180. Anybody get x? Sorry, that.
15.
X equals 15. If we do this one, I'm going to rewrite it over here. 8y plus 120 equals 180. Subtract 120 on both sides. Did I do that right? Did I do something wrong? 8y equals 60. Then do what? Divide by 8. So y equals what? 7.5. Now again, later on in the chapter, when you see this, you're going to know that this is another kind of four-sided figure that we're going to talk about. And these diagonals, as they go through there, they're always going to be perpendicular to each other. They're always going to form right angles. And we're going to know that because of these four sides being congruent to each other.
Number 5, 430.
Number 5 on 430. Number 5 on 430. On these, you got to be able to do these ones with graphs, because I like these because it shows me that you know how to graph, you know how to deal with slope, midpoint formula, all that stuff. -2, 4. If I graph something wrong, please tell me. -1, -1. 3, -4. And 2, 1. Does that read? We're trying to decide whether that is a parallelogram, and we're trying to use the distance formula and the slope formula. Now on this, what you need to do, remember we had those 5 ways to prove something was a parallelogram? Well, what they're telling you to use is that last one, which looked like this. You know, one pair of sides are congruent and that same pair of sides are parallel. So if we can show that about either one of these pairs of opposite sides, then we know it's a parallelogram. It doesn't matter which sides we choose, so pick 2 sides that we're going to use. ST. So the first thing with ST I'm going to do is I'm going to find the slope. How much did I go up? 6? 5? Do I need to put my finger here and count it for? Ready? Is everybody ready? Count for me.
6.
How much did I go up? 5, that's our rise. How much did I go over? So the slope of that is 5 over 1 or 5. That slope should be the same as the slope of what other segment? Say it again. VU. So I go from U to V. How much did I go up? Do we have to count it again? How much is it? 5? How much over did we go? What's that tell us about that too? If the slopes are the same, what do you know about them? Not congruent. They're parallel to each other. So that we know that those two are parallel. Is that enough to say it's a parallelogram? No, we still got to find the length of both of them. How do we find the length of those two segments? Distance formula. Be ready, because I'm going to write down the first one, because we're probably about out of time, right? I'm going to write down the first one, and then I'm going to write down the second one. Somebody do the first one for me, and I'll do the second one. That way we can get more stuff in. For ST, be looking at your paper, because I don't have my paper out, and everybody be looking. I'm going to make this bigger. For S and T, distance formula looks like this. Somebody tell me the x coordinates for the points S and T. -2 and -1. So that's going to make that a plus there, right? That's the x coordinates. Everybody agree with that? What's the y coordinates for S and T? 4 and -1. So that's going to make that a plus. Can you guys solve that for me? Somebody else help me out? I'll do it. S and T, or I'm sorry, V and U. For V and U, we want the x coordinates. And remember, we're on problem 5. So we got 3 minus 2 squared plus -4 minus 1 squared. 3 minus 2 is 1. 1 squared is 1. -4 minus 1 is -5. -5 squared is 25. 1 plus 25 is 26. The square root of 26 is about 5.1. So my segment's 5.1 long. How long was your guys'?
1 is 1 time.
What is it?
1
It's 1. So we're not finished yet.
and 25.
25. Add those together. What do you get? 26. What's the square root of 26? 5.1. What's that tell us about these two? Not parallel. They are congruent. So if this side is parallel, we said that up here, if those two are parallel and they're congruent, then what do we know about this shape? Yes, is a parallelogram. Now that's like a proof, because you actually have to show your work to show things out. Next question. Don't be trying to cheat, Jonathan.
Number 10.
Did you turn that off on me?
432.
Number 10 on 432.
Yeah.
Number 10 on 432. Everybody got that so I can get rid of it? Oops, wrong one. So I'm wasting time. Number 10 on 432. Can you see that red, or do I need to switch it?
I can see it.
I don't know, Bobby will see it. What do you know about the diagonals in a parallelogram? What do they do to each other? Say it louder. Cheer.
I said bicep.
They bisect each other. Say it louder. They bisect each other. So right away, what can I do with those two things?
Oh, we put them together.
Add them? What do you know about them? If this is, they're the same. So what equation can you set up? Somebody solve that for x while I look at the other one. And what do we know about these two segments? They're the same also. I'll solve for y. Somebody else solve for x. So we're going to set this equal to that. So y plus 23 equals -4y minus 2. On mine, I add 4y to both sides. 5y plus 23, sorry, I'll be quiet so I'm not messing any of you up. Somebody help me out, what's negative 25 divided by 5? So that's our y. Did I find x yet? Come on now. Is your arm broke or something? Probably want to go down and talk to your buddy about it. See if he'll let you go to the nurse. Yep. Seems like he's in a good mood today. I love talking to you. -6, anybody else get that? Clayton, did you get it, or are you just going with Riley? Because that doesn't sound right to me. -6?
Dang it, I trusted you.
That's what you got? All right. Doesn't sound right to me, but we'll go with it.
It's okay, Riley.
Jonathan, you're looking at it like you don't think it's right. Did you get something different? Rework it, Riley. See. Hurry up now. If everybody reworks that and we come up with something different and we fix it, I'll do one more problem. If nobody comes up with a different answer, I think it's wrong. Then we'll stop and we'll not do anymore. It says negative 2x plus 6 equals x plus 12. So now we got -2, we got -6.
That's -2.
Keep working. -2. -2. Dustin up here just pushing buttons on his calculator, trying to make me think that he's doing something.
Yep.
X is -2, is that what we're going with? Riley, you know what you did on the first one?
Yeah.
Messed up a sign, didn't you?
Yeah.
Give me one more problem then, since we fixed it. 8 on, which page was it? Last page? 8 on the last page. Sorry, I'm changing colors this time, I couldn't see that. Isn't this the same problem?
Pretty much.
Almost, yeah. Identical.
They're confusing.
What equation set up there?
-4x minus 2 equals -3x plus 4.
Somebody solve that. I'll solve the y's. I got the easy one this time. Y equals 13. Anybody get x yet? 6? Yes? 6? We're just gonna go with Riley. -6. So I got two different answers. I got 6 and -6.
It's -6.
-6. Another vote for -6. Make this a democracy. Won't help you with your grade because when I mark it wrong, if it's wrong. Anybody else get it? So right now, the vote's 2-1. We're going with -6. Fine with me. I don't think so, but.
You think you're negative
You
6.
got positive 6? Trevor's got positive 6.
I got negative 6.
So now we got 2-2 vote. Why is nobody else working these? What's going on? Yeah, this is algebra stuff. Should every one of you know how to do this? Otherwise, you should have been
It's negative
still in algebra
1
class, not
y.
in my
You have
class.
to divide by
6.
negative 1
Huh?
to get the, yeah.
I should have been.
Tell me how to solve it, then I'll solve it right up here.
Okay.
Take your negative 3x and you gotta add it to your negative 4.
You get negative 1x.
I'm working this problem.
You get what?
No, right.
Negative
Okay,
1x.
then you get negative 1x minus your 2 equals 4.
Everybody better be watching, because I'm not,
And then
if
plus your positive 2.
anybody tells me, if Clayton tells me to write down something wrong, I'm just writing it down, I'm not even.
And then you take your negative 1x down to your equal 6. And then you divide it by negative 1. And 6 divided by negative 1 is negative 6.
So another vote for negative 6? Is that what we're going with?
Yeah.
Alright. Make sure your names are on those. You can lay them right up here on the little table. As you get back to your seat, start copying this stuff down.